Hello, everyone, and welcome to the webinar on how to become a big data engineer. To introduce myself, I'm Hrishikesh, and I have over 17 years of IT consulting experience in the industry. Having said that, now let's get to the agenda for this particular session. We will begin by understanding who is a big data engineer. What does a big data engineer do? What are the roles and responsibilities? We will also see what is the difference between a data engineer and a big data engineer? What are the responsibilities of a big data engineer? What are the different skill sets, technology-wise, required by the big data engineer? What are the different big data engineering learning paths? And finally, the important thing is salary trends. We will also have a look at the kind of jobs these people can get. Let's talk about the first point. Who is a big data engineer? So if you go for the classic definition of big data engineering, somebody who works with data, and in this case with big data, right from acquiring the data to analyzing the data to visualizing the data to telling a story to the business, all of these different categories actually fall under big data engineering. So in a simple words, the big data engineers are the ones who develops, constructs, tests, maintain the complete architecture of the large scale processing system. We call it large scale because we are talking about big data. It's always large, correct? So these are the four main activities involved. And a person who is responsible for all of these things is nothing but a big data engineer. Let's further drill down the job role of the big data engineer. Let's try and understand more about what these guys do. So the crucial tasks included in the big data engineering job are designing, developing, constructing, installing, testing, and maintaining the complete data management and processing system. I talked about acquiring the data, wrangling the data, processing the data, analyzing the data, and visualizing the data, telling a story. All of this is what the big data engineer role is. Then building highly scalable, robust, and fault-tolerant system. They are the architects of these kind of systems. Taking care of the complete ETL process, correct? They have to make sure that the data which is coming into the system used by all the further steps is correct and complete. So they are responsible for the complete ETL process. Ensuring architecture is planned in such a way that it meets all the business requirements. The data is very crucial. Whatever the data analysis we are doing, that is the next step. But the data which we are acquiring needs to be right, pertaining to that particular use case or a business for which we are collecting. So that is also big data engineers' responsibility, ensuring that thing, and then planning the architecture accordingly. Discovering various opportunities for data acquisition and exploring new ways of using existing data. As we are talking about big data, the data comes from disparate sources, various sources. It's a heterogeneous data coming from various other sources, different formats. So this fellow needs to be aware of all those things. Okay, he needs to be aware of the different opportunities from any type of data that he can use and then combine those with each others to find out some final insight, to get some final insight. Okay. Then proposing ways to improve the data quality, reliability, and efficiency for the whole system. Correct? Once he gets hold of the data, then improving that data by means of cleansing it, getting rid of the noises in the data and those kind of things. Then we have creating a complete solution by integrating a variety of programming languages and tools together. You might be aware of various programming languages such as your Java, Python, Scala, R, those kind of languages which are mainly used in the big data analysis, statistical analysis, and those kind of things. So this fellow needs to be aware of these things. He should be capable of integrating all of these different things. Learning all of these programming languages might not be a very viable or possible option, but then at least being competent in at least one of the important programming languages such as Python is very important. So programming languages you definitely cannot bypass if you want to become a successful big data engineer. Then creating data models to reduce system complexity and hence increase efficiency and reduce the cost. Cost is the driving factor in every system. So you should be able to put together all of these different technologies that you know of and then create a cost-effective architecture out of that for your business. Deploying disaster recovery techniques. The data is very important, and the data is sitting on these kinds of servers and those kind of things, right? So servers are what? Servers are hardwares, and softwares are prone to fail sometimes. So in those cases, securing the data, providing fault tolerance is very important. So they should be also capable of deploying the disaster recovery techniques for the data. And then finally, introducing new data management tools and technologies into the existing system to make it more efficient, right? If till yesterday you were doing data engineering, then now today you're doing big data engineering, correct? So for big data, we do not have any dependence on the legacy RDBMS systems anymore. We need newer big data systems like Hadoop and many other big data frameworks, NoSQL databases, other programming languages. So you should be aware of all these things, and you should be capable of introducing the new data management tools and technologies into the existing system to make it even better and to make it suitable for the new business requirements and data processing needs. Okay, so this is all what a big data engineer do. If you want to do all these things, if this is something you see yourself doing, then big data engineering is a right field for you. Okay, so next I would like to address a very common confusion, that is the difference between the big data and the data engineer. Okay, very briefly, we will go through this difference. It is very important. Many people make mistakes over there, but then the difference is actually very small and simple. We are in the age of data revolution. So where data is the fuel of the 21st century. So various data sources and numerous technologies have evolved over the last 2 decades. Very often keep talking about big data and those kind of things. And the major ones are NoSQL databases, big data frameworks. So with the advent of big data in data management systems, the data engineer now has to handle and manage big data, and their role has been upgraded to big data engineer. So that's all the difference is. Now you're no more talking about a small piece of data, small volume of data, a specific structured data, the RDBMS systems to house and process that data. You're talking about big data technologies now, NoSQL databases, Hadoop systems, real-time processing, and all of those things. So due to big data, the whole data management system is becoming more and more complex. So now big data engineer has to learn multiple big data frameworks and NoSQL databases, right? So it has definitely become a role which should be capable of wearing multiple hats, not just one technology. I mean, those days are gone when you knew only Java or Oracle or only RDBMSs. Now you need to know a little bit of everything, right? T-scale set, as you call it. You should be thorough in one technology, let's say Python or something like that, Hadoop. And then you should know a little bit of everything. Jack of all trades, master of one. Okay, so that's what is really required. And that's what is basically the difference between the data engineer and a big data engineer. Okay, so advancing further in this webinar, let's now understand the responsibilities of a big data engineer. This would help us to map the big data engineering responsibilities with the required skill set. Now, this is very important section here in this webinar. What are the responsibilities and what are the skill sets which will help you? So first of all, we will see the responsibilities and then we will explore the technologies. There are 3 responsibilities that the big data engineer has: the data ingestion, data transformation, and performance optimization. So what is data ingestion? Data ingestion means taking the data from the various sources and then ingesting it into the data lake. Now you hear this term data lake a lot. Data lake is nothing but a dumping area of data wherein you can get data from various sources irrespective of their sizes, formats. Just put it there. And then later on, you might have various consumer systems which will read the data from that in the format they want. So there are a variety of data sources with different formats and structures of data. So data engineers needs skills to efficiently extract the data from the sources, which can include different data ingestion approaches like batch and real-time extraction. There are various other skills which would make the data ingestion more efficient, like incremental loading, and then loading the data parallelly, incrementally, those kind of things. So when it comes to big data world, the data ingestion becomes more complex as the amount of data starts accelerating and the data is also present in different formats. It's a very fast moving data. It's a very diverse data as far as the formats are concerned. It's a very huge data, correct? So it's a pretty complex. It's not as simple as handling a normal data. So big data engineer also needs to know data mining and different data ingestion APIs to capture and ingest more data into our data lake, wherein you're dumping all of that data. Then we have the data transformation. Once we have the data ingested wherever, I mean, the staging area, the data lake or whatever, we need to now transform that data because it is coming from various sources. It might be in disparate, it might be in heterogeneous format, various formats. So data transformation is required. The data is always present in the raw format, which cannot be used directly. As they say, the data itself doesn't have any value. It's just a heap of sub-characters, binaries, and those kind of things. But when you apply analytics on top of that, when you find patterns out of that, that is information, correct? So it needs to be converted from one format to another format or from one structure to another structure based on the use case. Okay, so the data transformation can be simple or complex process depending on the variety of data sources, formats of data, and the required output. What kind of trend analysis, what kind of analytics we are planning on that data. It will depend on that. So this may include various tools and custom scripts in different languages depending on the complexity, structure, format, and the volume of data. So if you look at these 4 keywords that I just mentioned, these are nothing but properties of big data. These are the challenges which are posed by the big data, the complexity of that data on which the big data engineer has to work. And lastly, the performance optimization. While doing all of this thing, the cost needs to be optimized, the performance of the system needs to be optimized. So building a system which is both scalable and efficient is a challenging work, right? So data engineers needs to understand how to improve the performance of individual data pipeline and optimize the overall system. So again, when we are dealing with big data platforms, the performance becomes a major factor because we are no more talking about certain megabytes or gigabytes of data now. It is in terms of terabytes, petabytes. Despite of being of such a huge size, there might be real-time processing expected out of that data. So it's quite complex, right? So again, when we are dealing with big data platforms, the performance becomes a major factor. Big data engineers need to make sure that the complete process from the query execution to visualizing the data through report and interactive dashboard should be optimized. The volume, the complexity cannot be an excuse. It has to be optimized despite of all of these things. So this needs various concepts like partitioning, indexing, denormalization, right? When the data is huge, we do not have to really compromise on the performance of that data processing. There are certain techniques, luckily, that we can deploy, and the big data engineer needs to be aware of that, such as the partitioning, indexing, denormalization, etc., etc. Correct? There are many others. So apart from these, a variety of responsibilities can be found in a big data engineer job. If you just pick up any JD job description, you will find all of these based on the tools and technologies which the industry is using currently. So now let's summarize the responsibilities of the big data engineer. He should be able to design, create, build, and maintain data pipelines efficiently, which perform efficiently. Aggregate and transform raw data coming from a variety of data sources to fulfill the functional and non-functional business needs. Performance optimization, that is automating processes, optimizing data delivery, and redesigning the complete architecture to improve performance and cost as well. It should be cost effective. So you can go to cloud also. So all of that is your choice. Handling, transforming, and managing big data using big data frameworks and NoSQL databases. Take help of any framework which is available for the purpose. And you should be aware of that in order to make use of them. Building complete infrastructure to ingest, transform, and data for further analysis and business requirement. So as a big data engineer, one of your responsibility might be preparing the data and provide it as a base for data scientists or machine learning engineers, and those kind of people who are going to use that data, correct? So all the wrangling, all the flattening of the data, transformations of the data needs to be done at your end, and that too on a correct data. So the data ingestion stage, data acquisition stage is also very important. Okay, so moving ahead, now let's look at the required skills that will get you hired as a big data engineer. So far, you must have really understood that this is definitely a role which requires you to wear multiple hats. Just one technology is not enough to become a big data engineer. So these are some of the skills that you will need to have. So the very first one is your big data frameworks, very important. Frameworks like Hadoop-based technologies. So with the rise of big data in the early 21st century, a new framework was born that was called as Hadoop. It was created by software engineers like Doug Cutting and Mike Caffarella for processing of such huge data. Because during those periods, companies like Yahoo and Google and Facebook were facing this big data challenge. Google was working to strengthen its search engine. So it was in the process of indexing the entire World Wide Web and store that data and then process that data. So as they say, necessity is the mother of invention. All of that resulted in these big data frameworks. And Hadoop was the pioneer. Hadoop was the first technology which came up as a solid big data technology. So there are a number of tools now in the Hadoop ecosystem which caters to the different purposes and processing belonging to different backgrounds. Okay, so now we will look at each one of these. When we say big data frameworks and Hadoop, Hadoop is not one single technology. Actually, when it started, it was a very humble start. It just started as a MapReduce, HDFS, and YARN, those kind of layers. But as time evolved, as the big data evolved, people started realizing that they require different techniques of visualizing, processing, analyzing that data. So the SQL-based technologies like Hive, scripting-based technologies like Pig, NoSQL databases like HBase, then ingestion tools like Flume and Scoop. Then we had real-time processing engines, Spark. Then we had streaming and messaging systems like Kafka and Storm, Spark machine learning library and Mahout for doing machine learning analysis of the data, workflow managers like Oozie. So all of these are nothing but your big data Hadoop ecosystem components. As a big data engineer, you will be expected, if not master all of these things, but at least be good and be able to use in your architectures some of these technologies. Okay, so the next one is your real-time processing frameworks. As I said, when big data evolved, when the technology evolved, just batch processing of the big data was not good enough. There were use cases wherein they wanted to have the real-time processing of the big data. So technologies like Spark came up. Okay, so real-time processing with quick action is the need of the hour. So either the credit fraud detection and those kind of use cases wherein you cannot wait for a transaction to go through, register it, and then process that the next day as a batch processing mode and get to know that the transaction was a fraudulent one. While the transaction is happening, my system should be able to analyze that big data and give me the pattern, give me the indication that the fraudulent transaction is going on and I should be able to stop it, right? So each and every one of them needed real-time processing. So it is a very important for big data engineer to have knowledge of real-time processing frameworks like Apache Spark. It can be easily integrated with Hadoop leveraging HDFS. Spark is a real-time processing engine. It doesn't have the cluster manager or it doesn't have the storage manager of its own. So you will very often find it implemented on top of Hadoop. So Hadoop will provide it distributed and parallel storage mechanism, while the Spark will be real-time distributed parallel processing engine, which allows you to process huge amounts of big data in real time. So for a big data engineer, these two technologies definitely are very important, the Hadoop and Spark. Then we have DBMS and database architectures. These are legacy RDBMS systems. Now, with the advent of big data technologies like Hadoop and Spark, they were never created to replace RDBMS. Okay, you can never say, let's remove Oracle and deploy Hadoop. If you do that, then you're doomed. Then you're committing a suicide. Because Hadoop is made for a different purpose and RDBMSs are made for different purpose. They are for OLTP processing, Hadoop is for OLAP processing, right? But then as a big data engineer, you will need to take care of data for both these types of processing. So apart from knowing new technologies like big data frameworks and real-time processing frameworks, you will also need to have knowledge about the legacy RDBMS systems. I'm calling it legacy not because they are gone, but now they are considered as old technologies, old ways of processing data. Okay, but they're still prevalent. They're still used very widely in the industry. So you need to know them. Then we have SQL-based technologies. So all your SQL-based technologies, all your RDBMSs, your PostgreSQL, SQLite, everything related to SQL. So structured query language is used to structure, manipulate, and manage data stored in databases. As data engineer, work very closely with the relational database, they need to have a strong command on SQL also. If you ask me one of the important skills, basic skills of a data engineer, what it should be, SQL is definitely one of them. You will not see a data engineer without having a knowledge of SQL. And when you're working with the databases like Oracle, then PL/SQL is also prominently used in the industry. PL/SQL provides procedural programming features to SQL. So if you're specifically focusing on Oracle, then PL/SQL will also be very useful skill set for you to have. Now, coming back to the new technologies that we have is NoSQL databases is also one of the important skill set for a big data engineer. As the requirements of the organization has grown beyond structured data, okay, if you are dealing with structured data, tabular columns and records, then the SQL and your PL/SQL and Oracle and those kind of technologies are definitely there. But as big data has an inherent property that it is unstructured, there is nothing structured about this data. So as the requirements of the organization has grown beyond structured data, NoSQL databases were created, right? So databases like Edge-based, MongoDB, Cassandra, DynamoDB, DocumentDB, those are nothing but your NoSQL database. NoSQL stands for not only SQL. Again, these were not made to replace SQL-based databases, but then they were made to do something which legacy RDBMS systems, SQL-based databases could not do because of the complexity of the big data. Okay, so they target the sparse schema, non-structuredness of the data and those kind of things. So NoSQL databases, it can store large volumes of structured, semi-structured and unstructured data with quick interaction and agile structure as per application requirements. If you use a lot of mobile application, a lot of mobile gaming, then you will see these kind of mobile apps or mobile games are backed with, not with the RDBMSs like Oracle and MySQL. They are backed with, as a backend, they are backed with these kind of databases. They are very fast NoSQL databases. But then again, they are not made for transactional processing. They have a very different use case for which they are made and for which they are very fast, right? So that is also one of the important skill sets that you need to know as a big data engineer. Now, next is your programming and scripting languages, right? The programming languages of the new era, new technology are Python and R. Various programming languages can serve the same purpose. Knowledge of one programming language is enough because at the end of it, everything is same. If you pick up Python, if you pick up SQL, if you pick up Scala, R, you will find similar structures, looping, constructs, and those kind of things, variables and those kind of things. Only the syntax will be a different. As the flavor changes, the logic remains the same. So if you're a beginner entering the big data world, you can go ahead with Python because Python is very popular these days. Python is used for various purposes. Apart from being general purpose knowledge language, it is also a language preferred for machine learning engineers, data scientists, and those kind of people. And it is also easy to learn because it has a very easy syntax and it has a huge community support as well. So learning Python and getting started in the big data world will definitely take care of one aspect of it, that is a programming language, right? Whether you learn any other programming language or not, Python should be your target. Now, R is also very important, but then R has a very specific purpose for which it was created, and the purpose is statistical analysis. So it is mostly used by data scientists, okay, because they mainly focus on statistical analysis and those kind of things. But then as a data engineer, you are going to be working with these kind of people, right? So having a little bit of knowledge of these things, if not all, at least Python. And if specifically you're going to work with data scientists, then a little bit of R will also not harm you. Okay. Then we have ETL data warehousing solutions. Like we have the Talent, ClickQ, SQL Server, then we have Power BI, those kind of tools. So data warehousing is very important when it comes to managing a huge amount of data coming in from heterogeneous sources. It is not just one source that you're getting it from. You might be getting it from various disparate sources. You need to apply ETL, extract, transform, and load on that. So data warehouse is used for data analytics and reporting and is a very crucial part of business intelligence. So it is very important for a big data engineer to master a data warehousing or an ETL tool. Now, most popular nowadays with big data is Talent. So you need not master all of these tools. You should be focusing at what is most popular in the industry. So in this category, we have Talent, very popular. So it is very important for you to have knowledge of at least one such tool. So after mastering one, it becomes easy to learn new tools as the fundamental remains the same, correct? If you know Talent, it is a drag and drop interface. Then Informatica, similar things, maybe a little bit of application or tool specific changes, but then the principle remains the same. So you can definitely use your knowledge of one tool to gain knowledge of other tool very easily, if at all you need to do that. And then finally, we have the operating systems. Linux, Unix, Solaris, then MS Windows for that matter, are the ones which fall in this category, these kind of technologies and tools. So industry-wide, various operating systems are used. Linux, Unix are some of the prominent used operating systems when it comes to big data. So big data engineers need to master one of them at least, right? So apart from understanding the complete data flow and business model, one of the motivation behind becoming a data engineer is the salary, correct? Not only the motivation behind becoming a data engineer, but then any work that you do, any role that you look to get into, the final motivation definitely, if not for everyone, but the majority of the people, is the kind of compensation, kind of salaries you get. So let's talk about the job opportunities and kind of salaries that these people get. So the average salary of a big data engineer ranges from $94,000 to $126,000 as per Indeed. Okay, now this might change depending on your experience level, depending on the industry you're joining, but these are typical salary ranges. Okay, it will change. I mean, if you are joining a manufacturing sector, then it might be a little bit less than the person who joins the investment banking and those kind of projects. So whereas according to Glassdoor, the national average salary for a senior data engineer is $181,000 in the United States. Okay, now you can convert it to your rupees or INR, whatever currencies you want to work in. So as of January 2023, the total number of jobs listed in renowned job portals like LinkedIn India, LinkedIn US, Indeed, Glassdoor US, there are thousands of jobs you will see for the big data engineers. Like the Glassdoor saw around 143K jobs. Then Indeed had 127K plus jobs. In LinkedIn US, we had 39K plus jobs. In LinkedIn India itself, you have more than 3,000 jobs for this particular category. So this is going to increase. It is estimated to grow exponentially in the coming years. Okay, so we will talk about the big data engineering learning path. We have certain courses at Edureka, which I'll be making you aware of. So I hope this big data engineering webinar has helped you in figuring out the right skill set that you need to become a big data engineer. Now, don't get overwhelmed or intimidated by all of these different technologies and all of that. If you follow a structured learning path, then all of it will become very easy. Of course, if you just try to do it on your own, taking help of Google, then there are huge chances that you will get overwhelmed, because for each of these technology nowadays, there are thousands of resources available for free even. But then that is not the way of learning or getting into these kind of profiles, because it tends to get very confusing. And if you get confused right in the beginning, then there is no way, get all of these prerequisites satisfied and get hired probably. So As a continuation to the topic that we have discussed today, let me now take you to the certification courses that Edureka has. As I said, it has a very systematic learning path laid out for you all aspiring to get into this lucrative world of opportunities. So as we saw the different skill sets and responsibilities, if you see this learning path, it has everything incorporated in that. Right from your programming language, operating systems, your DBMS, SQL, NoSQL databases, ETL and data warehousing, big data frameworks, real-time processing frameworks, cloud-based technologies. Edureka has courses, various courses for all of these different things, and it takes you in a very systematic way. So we have a course called Big Data Hadoop Certification Training Course with Edureka, which is 30 hours of learning, systematic learning, in which we take you from the basic levels all the way to the advanced levels. So if you are complete new to the industry, then it will start with the basics of big data, then understanding HDFS, MapReduce, then topics like Pig and Hive and HBase. And then you get to learn the real-time processing engines such as Spark, then 𝐿, and finally, with the real-time project, including comprising of all of these technologies, you definitely become a master of all of these technologies. So according to me, this is definitely a launch pad for you to get into the big data world. And then the opportunities are endless. You can get groomed in any one particular stream, any one particular specialization, and then get to where you want to go. So with that, we come to the end of the session. Thank you very much, everyone, for attending. Bye. Take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!